All right, so what we're going to do here in this video is we are going to look at how to make a velocity versus time graph from a position versus time graph. So let's quickly review what's going on with a position versus time graph. We know that this is describing where at any given time, okay? At any given time, we can figure out between 0 and 5 seconds where this thing is. We know that, for example, the y-intercept is the starting position. Okay, and we also know that the slope is the velocity. And we could use y equals mx plus b to figure out where it is at any given point. Well, where this position versus time graph is telling you, again, where an object is at a certain time, this one is describing how fast it's going, its velocity at any given time. So instead of reading off like the mile markers when you are traveling down the road, which would be a position versus time graph, a velocity versus time graph would be you yelling out what the car's speedometer is reading. You know, that would be a similar type every moment. All right, so how in the world can we go from one to the other? Well, again, the slope of this is going to describe the velocity. So let's just look at the first second from 0 to 1. All right, and see what we can come up with over here. Again, we got to find the velocity. So let's describe the velocity for just the first second right here. Okay, so if I want to find the slope, all right, I need the rise over run, and the rise is 2 meters. Okay, so it went up from 0 to 2, and it did that in 1 second. All right, so that's going to be the velocity, which is 2 meters per second. So that means from time 0 to 1, okay, just this section right here that we're interested in, the velocity would read 2 meters per second. Okay. Let's change it up for this section right here. All right. So the velocity for that section, well, it went from 2 to 4, so that means the change in position was, again, 2 meters. And the change in time from 1 to 2 is 1 second. So once again, 2 meters per second. And if you just kind of look at the graph, again, this is a straight line, which means as a constant slope. So we don't have to break it down every instant in this case. We know that for the remaining parts of this graph, all right, in fact, for the whole thing, that the slope is always going to be 2 meters per second. So a velocity versus time graph would just be a nice flat horizontal line at 2 meters per second, because the slope of this position versus time graph at all points of the time is a 2 meter per second. A few things tip-wise for velocity versus time graphs in Unit 1. We're talking about unified motion here, which is just basically saying it's moving at a constant rate. So all of these have a slope of 0 in this unit. Only in this unit when we're talking about constant, because these will always, position versus time graphs will always be a nice straight line. What will change is the y-intercept. Okay, the y-intercept is actually telling us the velocity, okay, at time 0. All right, or in other words, its initial velocity. Now, since it's not going to change its velocity, that initial velocity is the same all the way across. So those are just some tips. You will always get flat lines for this unit. Next unit, it will change. Let's go to another one. All right. So if we want to come up with a velocity versus time graph for this guy here, again, we need to know the velocity. Now, velocity, all right, again, it's rise over run, but really what that means is we are trying to find its displacement, the change in position, over a given amount of time. So we're really using this equation for velocity. All right, I'm going to pick that spot and that spot to figure out this stuff. All right, so that's a displacement of 2 meters, and the time it takes to go from that point to that point is 5 seconds. So my velocity, again, displacement over time, is 2/5 meters per second. 2/5 is like 0.4, all right? So that's the same thing as 0.4 meters per second. If you wanted to leave it in decimal place or decimal form, that's fine. So you just draw a horizontal line all the way across. Again, the slope at any point on here is 0.4 meters per second. It's going up 2 meters for every 5 seconds. All right, that's unchanging. It's a constant with these straight lines. That's why this is a flat line here. Let's do one more. All right. So we got a line, right, that's decreasing in its value of the position, but it's decreasing at a constant rate. That's why it's a straight line. So it went from 10 meters down to 0 meters. That means it's a displacement not of 10, but of -10 in time of 5 seconds. So when we punch that into our equation, we get a velocity of -2 meters per second, which means when we come over here, all right, the whole velocity versus time graph has a horizontal line at -2 meters per second because the velocity was not changing over time. All right, the velocity was always -2 meters per second, -2 meters per second, -2 meters per second, -2, -2. That's why this is a straight line here with a given slope, and that's why this one is a flat line. So that's how you do velocity versus time graphs from a position versus time graph.